In this video, we'll look at a really nice example of a tree diagram that's got a bit of a kick and a bit of a flavor for us. And so what we've got is 200 tourists visiting the same restaurant on 2 consecutive evenings, Lucky Fishes. On both evenings, the tourists could either choose beef or chicken for their main meal. And the manager observed that 35% of tourists chose beef the first night and 70% chose chicken the second night. And we've got to draw a tree with all the possibilities. And so for starters, on the first night, if 35%, so 0.35 liked beef, that's implying that the rest, 0.65, must have had chicken. So that 1% can actually elicit 2. On the second evening, so this is the second branch, they said 70% like chicken, and so that's 0.7. So by saying that, they're telling us that 30% must have liked beef. And this is still representing the second evening here, and so the percentages would be the same. It was 70% liking chicken on the second. And so if I want to get my answer, the probability of someone liking beef and beef again would just be 0.35, and because it's and, we times our answers. This would be the probability of beef and chicken, which is 0.35 times 0.7. This is the probability that I'm going to have chicken first and then beef. So that's 0.65 times 0.3. And lastly, chances I'm going to have chicken on both nights is 0.65 and 0.7. And so let me just take a minute to work out these probabilities, and you can see if this all makes sense for you. So the first final answer for getting 2 nights of beef is 0.105. Getting beef and then chicken will be 0.425. Getting chicken and then beef is 0.195. And lastly, 2 nights of hunder of chicken, you get 0.455. So if they then say calculate the number of tourists who chose the same meal, that would be these guys who had beef and these guys who had chicken. And so I'm going to add those 2 probabilities together. And when I add those 2 probabilities together of getting beef, or I could have had chicken, so I plus, I get an answer of 0.56, which represents 56%. And if I want to work out the number of tourists, I'm just going to times this by the number of tourists. And so when I times that by 200, I get my final answer of 112. 112 people liked having the same meal on both nights, and show that more tourists opted not to change their choice of main meal during the 2 visits. Well, we know that 112 like to get the same meal, and so therefore how many changed their meal? It would be 200 minus 112, 88. And so 112 kept the same meal, which is more than 88. Therefore, more people opted to have the same meal at the restaurant both nights in a row. I hope that you found this tree diagram question helpful. If you did, please like it, subscribe to our channel, and share it with your friends. Thanks.